In this video, we're going to talk about the reaction quotient. Now, in the previous video, we talked about K and how to solve K using an ICE table. But let's say we're trying to do that and we want to know, well, are we going to gain more products or are we going to gain more reactants? That is, which way is our reaction going to flow? How can we determine that if we're just given a mix of chemicals? And that's where the reaction quotient comes in. And the idea is we have to compare, what's our current ratio of concentrations to our equilibrium constant or our equilibrium ratio. And the non-equilibrium concentration ratio of products to reactants is Q. Another way to think of Q is it's the same equation as K, you're just not as at equilibrium. So Q is that value anytime you're not at equilibrium. And we can look at that here. So if we have A plus B goes to C plus D, Q is C raised to the power of C, D raised to the power of D, divided by A raised to the power of A, B raised to the power of B. Or you can do that for pressures as well. So you can see Q is the same exact thing as K, but the concentrations you put in are any concentration that is not at equilibrium. If you put in concentrations that are at equilibrium, then that is a reaction quotient. Or sorry, that is your equilibrium constant. That is your K. Q, reaction quotient, is any concentration not at equilibrium. All right. So let's see how we can use this. And we can use this to determine which way our reaction is flowing. So let's say we plug in, we are given some concentrations at some time point, and we want to know if we're above equilibrium, below equilibrium, or equal to equilibrium. And by above, below, I'm talking about comparing the value of Q to K. All right, so let's say our value of Q is bigger than K. That means our numerator is bigger than our denominator. That means we have a higher amount of products than we do reactants. Higher amount of products than we do at equilibrium. That means our reaction will flow from the products to the reactants. It will flow in reverse. And we can see that here. So here's our equilibrium concentration. So our ratio would be 1.45. If our Q is bigger than a number of 1.45, we need to make that number smaller. And the way you do that is by making more reactants. Now if our Q is less than K, we have a number smaller than 1.45. That means we have more reactants than products. If you have more reactants than products, you have to make more products. So our reaction is going to go in the quote-unquote normal direction. It's going to run to the right. You're going to make more products. And your Q is equal to K, you're at equilibrium. Your concentrations aren't going to change, and what you actually calculated wasn't a Q, it was a K. Now, if your reaction mixture is just reactants, you would have no denominator. 0 divided by anything is 0. So your Q is 0, and you'll go in the forward direction. While if you have only products, you'll have products divided by 0. We say that Q is infinity then. It would actually be not a number, but what that means is that you're going to run towards your reactants. You're going to make reactants. And let's see how we use this with an example problem now. So let's say we have a reaction. NH4HS goes to NH3 plus H2S. This is reversible. And we know that our Kc is 8.5 times 10 to the minus 3. So let's say we have a reaction that is solid NH4HS. And remember, we said in the previous video, solid concentrations don't change, so its concentration does not matter. the concentration of NH3 is 0.166 molar. The concentration of H2S is 0.166 molar. So the question is, will we form more reactants or products? And to do that, we have to figure out what the Q is right now. So both Q and KEQ is equal to NH3 multiplied by H2S, the concentrations. All right. So Q equals 0.166 times 0.166. So Q is 2.8 times 10 to the minus 2. Q is bigger than Kc, therefore we're going to run in reverse. We need to get rid of some of this product, and so we're going to make more reactant. So we're going to flow from right to left here. And that's it for this video. I'll see you in the next video.